Did you know that the engines powering our modern vehicles have their roots in the same technology that fueled Industrial Revolution? In this video, we explore the evolution of the combustion engine from steam to today's high-performance engines. Stick around till the end for a glimpse into the future of these engineering marvels. Hi, I'm Hari from HistEduHub. Today, we are diving into the fascinating world of combustion engines. We'll start with the external combustion engine which powered the Industrial Revolution and then move on to the internal combustion engines that drive everything from cars to aeroplanes. Whether you're a student, engineer or just curious, this video is gonna give you a solid understanding of these powerful machines. The external combustion engine, where fuel is burned outside the engine to create steam, was a monumental invention in the 18th century. The steam engine of James Watt didn't just power a machine, it powered an entire revolution, enabling factories to operate at an unprecedented scale. These engines were the driving force behind the railroads and ships, making long-distance travel and trade possible. However, they were massive, requiring significant amount of fuel and space. But their impact on industrial growth is undeniable. Imagine a world where steam powered near everything from massive trains to entire factories. This was the power of external combustion engine. Despite their size and fuel demands, external combustion engines were critical to the rise of industrial societies. They were the backbone of the early industrial economy, enabling mass production and laying groundwork for the modern world. Did you know that the first steam engines were designed to pump water out of coal mines, enabling deeper and more efficient mining operations? Internal combustion engines, where fuel is burned inside the engine, represented a revolutionary leap in technology. Unlike their steam-powered predecessors, these engines were smaller, more efficient and could be used in a variety of applications. Inventors like Nicholas Otto and Carl Benz didn't just create engines, they laid the foundation for modern transportation. By the late 19th century, these engines were propelling automobiles, ships and even early aeroplanes, marking the dawn of a new era in mobility. These engines were a major leap forward, more compact and versatile. They powered the cars and planes that defined the 20th century. The impact of internal combustion engines cannot be overstated. They didn't just make travel faster, they made it accessible, paving the way for global connectivity. As these engines evolved, they became more powerful and efficient, driving the technological advancements that shaped the modern world. Did you know the first internal combustion engines were used to power stationary machines before being adapted for vehicles? At the heart of most internal combustion engine lies the four-stroke cycle: intake, compression, power and exhaust. This cycle effectively converts fuel into mechanical energy, driving everything from cars to industrial machinery. During the intake stroke, the engine takes in air and fuel. During compression, this mixture is compressed within the cylinder. The power stroke is where the magic happens. Fuel ignites, driving the piston, which in turn generates power. Finally, the exhaust stroke expels the burned gases, making way for the cycle to begin anew. Let's break down how this works. Imagine your car's engine going through these four stages every time you hit the gas: taking in air, compressing it, igniting the fuel and then expelling the exhaust. Understanding this cycle is crucial for anyone interested in how engine works. It's a marvel of engineering, balancing power and efficiency in a compact design. The power generated during the power stroke is what propels vehicles, making internal combustion engines the workhorses of modern transportation. Did you know the efficiency of internal combustion engines has been steadily improving with advances like turbocharging and direct fuel injection? There are several types of internal combustion engines, each tailored to a specific need. Gasoline engines are most common, found in millions of cars worldwide. They are known for their balance of power and efficiency. Diesel engines, on the other hand, are favored for their fuel efficiency and durability, making them ideal for trucks, buses, and heavy machinery. These engines operate at a higher compression ratios, allowing them to generate more torque, which is crucial for heavy-duty applications. Additionally, there are rotary engines which offer a unique design with a few moving parts, though they are less common. Did you know that the diesel engines don't use spark plugs? Instead, they compress air to such a high degree that the heat ignites the fuel. Each type of engine has its strength, and choice of the engine depends largely on the application. Diesel engines, for example, are often used in commercial vehicles because they provide more power and more fuel efficient over long distances. Meanwhile, gasoline engines are preferred in personal vehicles for their smooth operation and availability. Despite the rise of electric vehicles, combustion engines are far from being obsolete. Innovations like hybrid engines, which combine internal combustion with electric power, are leading the charge towards more sustainable future. These engines offer the best of both worlds: reduced emissions and improved fuel efficiency. Additionally, alternative fuels like hydrogen and biofuels are being explored to make combustion engines cleaner and more environmentally friendly. Engineers are also developing new materials and designs to make these engines lighter and more efficient, ensuring they remain relevant in a rapidly changing world. While electric vehicles are gaining popularity, combustion engines aren't going anywhere anytime soon. Innovations like hybrid engines are showing us how these technologies can coexist. Hybrid engines in particular represent a significant step forward in reducing our carbon footprints. By using electric vehicles for short distances and combustion for longer trips, they offer a versatile solution for modern transportation. The future of combustion engine lies in these kinds of innovation, which aim to make them more sustainable while retaining their powerful capabilities. Did you know that the hybrid engines can significantly reduce emissions and fuel consumption, offering a transition to a greener transportation? So from steam engines that powered the industrial revolution to today's hybrid engines, combustion engines have continuously evolved, driving technological progress. As we look into the future, these engines will continue to play a crucial role in transportation and industry. If you have stayed till now, how about a like and comment? You can even consider subscribing to HistEduHub for more insights into history, education, and engineering.